Welcome back to Max Lecture Series. So in this series, so far we understood how to obtain the complementary function when higher order differential equation is given. And I also told you that whenever higher order differential equation is given to us, we will be having completely two solutions. What are those? Can you recapture? Yes. So there are two solutions. One is called complementary function and another one is called particular integration. But I have also told you that the value of particular integration will become 0 when the right hand side of the higher order differential equation is 0. If the right hand side of the higher order differential equation is not equal to 0, then particular integration will be existing. And we saw whenever complementary function, we are trying to estimate complementary function, we saw different approaches based on the roots that we are obtaining. If the roots are real and non-repeated, if the roots are real but they are repeated, if the roots are imaginary, then how to write the solution. If the roots are complex, then how to write the solution. Everything we have to observe, we have been observed in case of complementary function. But now the question is, suppose if in the question right side function is existing, then how to obtain the complete solution for the given equation. If you observe the given equation, here we are having on the right hand side we have something. So now the question is, obtain the complete solution for this function. We have to obtain the complete solution. How will you write down? See, always in the higher order differential equation, observe the numerator. In the numerator we have dependent variable. In the denominator we have independent variable. Now this can be written as, we are trying to obtain the solution for the dependent variable x with respect to t. It is depending on the value of t. Now this can be written as, we will be having two solutions. One is called complementary function and another one is called particular integration. Now this is going to be the complete solution. Let us explain one by one. Always while finding the complementary function, don't keep your attention with the right hand side, because right hand side will be useful only with the particular integration. It will be used to estimate the particular integration portion. So while estimating the complementary function, just consider only left hand side, equate it to 0 and approach the same procedure that we have been observed so far. Now see, if you observe on the left hand side, we have d square x upon dt square plus what we have 3 times of dx by dt. So I can write 3 times of dx upon dt plus what we have next, we have 2 times of x. So for your understanding, simply I am writing such that you can write like this. So I am writing this only to obtain complementary function. So first keep the heading complementary function. Take only left hand side equation, just equal it to 0. After that, see there, now you know how to reduce this expression. From this, we have to replace this d square by dt square by capital D square into x plus 3 times of d by dt will be replaced by capital D into x plus 2 times of x will be equal to 0. Now from here, what we are going to do further? Take your dependent variable in common outside such that the resultant can be written as d square plus 3 times of d plus 2 equal to 0. Now see that this is going to be our characteristic equation. How will you break these roots? Sir, it is very simple. If you observe, product of 1 into 2 will give you product 2, addition of 1 plus 2 will give us 3. So these roots can be broken as d plus 1 into d plus 2 equal to 0. From this further we can write d equal to minus 1 and d equal to minus 2. See there, our roots are distinct. Distinct means we are having two different values, minus 1 and minus 2. How will you write down the solution for this? So from this I can write the complete solution for this going to be complementary function is going to be, can be written as two arbitrary constant a and b, and then we have to put addition, write exponential, then in the power substitute the values of root minus 1, minus 2. After that it will be multiplied by the independent variable. Which is our independent variable? T is our independent variable. See, we saw t is our independent variable, x is dependent variable. So I have to write, we know how to write down the complementary function. Now treat this one as your equation number 1. See, in the next lecture onwards, When a complete equation is given, I am not going to calculate complementary function, because already we have been seen how to calculate the complementary function. It is unnecessarily wasting our time. So you have to do by yourself. I am going to teach you how to calculate the particular integration. As we saw while calculating the complementary function, we have been seen different types of models. Based on the roots, we have been wrote the complementary function in different way. In the same way, we are going to write down the particular integration also. For the particular integration, I am going to teach you different way of methods, but they all are very easy. See, let me tell you, whenever on the right hand side you are observing exponential function, first one, see there, either it should be exponential or it should be a constant. In both of these cases, you have to approach the same method. Same method means what method, sir? Let me tell you. See, from the complementary function, you can observe, see there, we are obtaining one characteristic equation, right? Yes, it is very simple. Step number 1, find this characteristic equation. When you are calculating the complementary function, you know the procedure to bring this characteristic equation, like how to replace d square by dt square by capital D square. Approach this procedure, obtain this characteristic equation. Now, take this characteristic equation. Let me teach you how to calculate the particular integration. So, the particular integration is going to be on the right hand side, whatever the equation that you are having. What you are having here, 5 times of e power minus t. Just to take that equation, write it in the numerator, 5 into e power minus t. Go to the denominator, just write down the characteristic equation that you have obtained from the complementary function procedure. What we have obtained, d square plus 3d plus 2. Just to substitute that characteristic equation, d square plus 3 times of d plus 2. After that, sir, what is the next step? It is very easy. I am repeating, whenever you are observing in the examination that you will be requested to calculate the particular integration, take the given differential equation. You know how to calculate the complementary function for the differential equation. While calculating the complementary function, we are always observing, that is, we are always obtaining one characteristic equation. Just to take that characteristic equation. So, next step, while calculating the particular integration, in the denominator substitute that characteristic equation, whereas in the numerator substitute all whatever the equation that is available on the right hand side. This procedure is common. First step is common. After that, based on the equation that is given on the right hand side, whether it is exponential equation or some algebraic equation will be given, or trigonometric equation will be given, according to the type of the equation that will be given, next step only will be different. First step will be same for all type of particular integration. This is the step number 1, and this step is common for all type of differential equation that will be given. Okay. Next step, immediately in the step number 2. Sir, what we have to do in the step number 2 is, I said whenever exponential function or some constant will be given. Let me tell you what is the difference. Constant means some value will be given on the right hand side, like 5 or simply 10, or simply they will give you 20, some constant value will be given. What you have to do is, whenever you are observing this type of constant value on the right hand side, just write down like this, 20, if suppose for an example, on the right hand side only simply 20 is given. See, in place of 5 into e power minus t, only 20 is given. In place of 5 into e power minus t, only 20 is given. Just assume like that. What you have to do is, just write down 20 into e power 0 times of t. Just write down like this, e power 0t. See, you know e power 0t equal to once again 1 only. So, 1 into 20. See, why I am writing t here? In place of t, actually we have to write the independent variable. Here the equation is dx by dt. It means t is independent variable, x is dependent variable. Denominator variable is going to be our independent variable. So, whatever the independent variable that will be given in your differential equation, substitute that variable here. If x is lies in the denominator, then write down x. If y is lies here, then write down y. But what you have to do, whenever you are observing constant, with that you have to write e power 0 with the independent variable that will be given in your differential equation. Suppose if your exponential equation is directly given, then there will be no issues. After that, what you have to do, sir? See, if exponential equation is directly given, go to the power of the exponential equation and observe the coefficient of the independent variable. See there, if you observe, in our case e power minus t is given. It means minus 1 is the coefficient of the independent variable. If constant is given, then 0 will be your coefficient of t. It is fixed. Whenever constant will be given, then 0 will become the coefficient. It will be fixed. If exponential equation is given, then coefficient of your independent variable is going to be a constant. Just to take that constant outside, I am giving some name for that. I am calling it as a. You can use any name. So a equal to -1. Next step, substitute all the places of d. You have to replace the d by this constant value. Then what you will be getting? See, in the next step, then it will become 5 times of e power minus t. Go to the denominator. I am replacing d by -1 whole square plus 3 times of d will be replaced by -1 plus 2. So what will happen now? This will going to give us 5 times of e power minus t upon -1 whole square will become +1. 3 times of -1 will give you -3 plus 2. What will be the final answer? See, 2 plus 1 will become 3. So what you will be getting here? 5 times of e power minus t upon 1 plus 2 will become 3. 3 minus 3 will become 0, sir. If it will become 0, then further what can I do? The thing is, if your denominator will become not equal to 0, suppose instead of getting 0 here I am getting some 4 or 5, then that will be your solution. You can directly write down your answer. Instead of that, if your denominator is going to be 0, then what shall I do, sir? If your denominator is 0, then nothing you have to do, just to go back to the first step. Again take the first step. Take the first step one more time. What is your independent variable here? T is our independent variable. Multiply your numerator by 1 time. Your your numerator will be multiplied by your independent variable only 1 time, and the denominator will be differentiated. See, in the denominator we are having d square plus 3d plus 2. We are having d square plus 3 times of d plus 2. Differentiate your denominator with respect to d. Then what you will be obtaining? This will give you 2d plus 3. Substitute that value in the denominator, 2d plus 3. Once again repeat the same procedure. Now what is the coefficient of your t? In the power we have -1. Replace d by -1. Now what you will be obtaining? 2 into -1 will become -2. -2 plus 3 will be giving us +1. So what is the answer? In the numerator we are having, I am writing, see, 5t into e power minus t. I have just interchanged the position. I am keeping t with 5. Divided by, we are having only 1, so this can be simply written as 5 times of t into e power minus t. This is how we are obtaining the particular integration when exponential function will be given. I hope you understood the procedure. Nothing is there. Just observe the coefficient of your independent variable which is lies in the power of your exponential function. Substitute that coefficient variable in all places of d. It doesn't matter whether it is d square or it is d cube or it is d power 4. Just to take d. In place of d, you have to substitute the coefficient of exponential independent variable. After that, if your denominator will become a non-zero value, if you are having some constant value 2, 3, 5, 10, 1000, whatever, if it is constant, if it is not equal to 0, then there will be no problem. Suppose if your denominator will become 0, then go to first equation, go to your numerator. We know from the equation, we know what is independent variable. Here independent variable is t. So multiply your numerator by the independent variable. You have to differentiate the denominator 1 time, then substitute the constant coefficient again. Sir, after substituting that one more time, once again if you are getting 0 in the denominator, then what you have to do? Repeat the same procedure. This time what you have to do is, already I have multiplied my numerator by c. What is our new equation? 5 into e power minus t. It is multiplied by t. Denominator has been differentiated 1 time. Now take this equation. Suppose if your denominator will become 0 once again. Second time also if you are getting 0, then repeat the same procedure. Take the numerator multiplied by t one more time. Differentiate the denominator with respect to d one more time. Then you will be getting the solution. So this is how we are obtaining the particular integration when exponential function will be given. I hope you all understood. I told two things here. Exponential function, another one is constant also. Constant means what will happen? E power 0 to you have to add. Here coefficient will become 0. So what you have to do? Go to the denominator. Wherever you have d, in place of d substitute 0. And observe the overall numerator will become constant or not. If the overall numerator will be overall denominator will become non-zero value or not. If it is 0, then apply the same procedure. Numerator will be multiplied by the independent variable, denominator will get differentiated. I hope you all understood this method clearly. So this method is only applicable whenever you are observing the exponential term on the right hand side or constant term. For some other case, there are some other cases, that things we will see in the next class. Before observing the next class, kindly observe one more time how to calculate the complementary functions for all type of differential equations. Those things already uploaded in our previous lectures. This is all for this lecture. Rest of things we will see in the next class. Thank you all.